Hello guys, welcome to S Academicus. So this is my third lecture on design of G+6 Rcc building. So in this lecture I'll be explaining the modeling of this G+6 Rcc buildings. So I have planned this video in the second lecture, but just not to make the lecture boring and long, I just cut it and I have just made a separate video. The second lecture was regarding your beam column placing, your slab type deciding the slab type. We have just marked the grid. So once you have marked the grid, based on those marking you can just mark the coordinate. So like if this, we can just mark the coordinates. So coordinates, how you'll mark, like if we are keeping first column here, or you are keeping the first column here, so we are just starting from point 1. So this will be your 0 0. So let's get into STAAD Pro. So STAAD Pro, just after, once you are done with everything, you just open STAAD Pro, click on STAAD Pro. Now we are just creating geometry. So the first node will be 0 0 0, 0. So this is the first node. So once your first node is decided, now your second node will be this. We are creating a node here because there will this first column, then second column. So this point is 3.25. So now just x will be 3.25. This modeling is along x and z direction. So x will be 3.25, y 0, which is z 0. Now once your x, y and z are 0, so now let's get back to the nodes. Next point is 3.3. So 3.2 plus 3.3, it is coming 6.55. So next point is 6.55, 0 0. So we have marked these three grids. Like we are giving a column here. We have also just used this. We will now just create the node. Later on we will just delete this node. We will work with this node. First, if we are creating this node because we can easily replicate those nodes. So just for replication, once these nodes are replicated, we can just delete these two nodes. So now we are just creating these two nodes. Later on we will delete this node. So that will be very easy to make the geometry. We can make the geometry within very short span of time. Now once this is done, this now 3.32 plus 2.85. So how much it is coming? 9.44. So it is 9.4. So next is 9.4. Once 9.4 is done, then it is coming around 13.3. 13.3. So 13 point, after 13.3, last. After 13.3, this is the last point, that is 16.55. So 16.55. So once we have the nodes along this grid, we have all the nodes. So first we can replicate these nodes at 2.945 meters. So we will just select these nodes. We will just select these nodes. We will select these nodes. These nodes are selected. Go on geometry. We have already uploaded video lectures on STAAD Pro, translational repeat. So for translational repeat, along we are replicating along z. This is negative, this is positive z, and this is negative z. So just we are replicating negative z. Spacing 2.945. So minus 2.945. Just click on OK. Now just look, this node is generated. Now this node is generated, so we can just delete these two intermediate nodes which are not required. So just delete it. This also delete. Now you can just keep on replicating these node at particular interval. Like if you just have a look along the AutoCAD drawing, so that this is 2.95, then we have another grid at this 1.885 plus 4.7, then 2.675, then 2.675 again, then 2.675, then we have 2.325, then 2.945. So we can just keep on replicating same we will do. So we have replicated this node as minus 2.325. Now again we will copy this and we will again use this translational repeat. Again positive Z is minus 2.675, minus 2.675. So this is again replicated same. So last node, the grid is at minus 2.945 distance from the second last grid. So we'll just go into the translational repeat, click on Z, spacing minus 2.945. Now again this if you just go to the AutoCAD, same geometry. So these two columns we have to just remove from here, like we have removed from here. So we have to remove from here. So just go into this, just select these two columns and just remove. I've just deleted these columns. Now we have to just join the beam. So just select all these nodes, beam nodes, just select all these nodes, just go into the geometry, connect beam along x-axis. So again connect beam along z-axis. So these beams are connected. Now you just need to remove these two beams because this is not required. This is also not required. So we can just remove these beams. Now let's just assign the support, then we will just go on replicating the number of stories. So just go to the general command, support, generate a fixed support. So just fixed support is already created. So just click a fixed support, add fixed support. Let's use this cursor. Now we are not assigning the supports. First we need to just translational repeat. We need to just provide a foundation depth. So use the translational repeat command along y negative direction. Why? Because height, we are going below ground level, so y spacing will be minus 1.5. We are giving 1.5 foundation, minus 1.5. So click on just click on geometry, translational repeat, y direction, minus 1.5 meter, minus 1.5 meter. Click on OK. So we have created the geometry. We have just replicated this foundation nodes. So just you need to just connect. So just select all geometry, connect beam along y-axis. This option is not available because we have used this command, we just need to just select this. So we control Z, I've just used this. So we have just connected all the columns negative direction, that is for foundation. Now let's get into the support. Assign the support. Select these nodes, this foundation nodes. Support assigned to selected, assigned to view, or assigned to selected. We just assign to selected nodes. So now support is assigned. So this ground level, few beams are not connected, few columns are not connected, so you can just click, you can just use this command, use geometry. You have to go to geometry, connect beam along y direction, so all beams are and all columns are added. So now your structure up to your plinth level, up to your ground level is generated. Now you just need to replicate this same structure up to ground plus 6, that is 7 story. So you don't need to do anything, just need to select these nodes, click on this translational repeat. Now positive y direction, you just need a floor to floor spacing is 3.2. how many steps we need, just keep it 3.2 default. We have 7 steps, number of stories 7, ground plus 6, that is 7. So ground, this is ground 1 2 3 4 5 6. And also just link step means all your nodes will be connected. Just click on OK. So now all the columns are connected. Now you just need to select all these nodes, click connect all along X, similarly connect all along Z. Now connect all along Z. So now those beams which are not required you can just remove, but this is the geometry we have made. So these nodes have been generated, these beams are generated. I'll just show you which are not required. So we just made a mistake while modeling, so just select and delete. You can delete, there is no, you don't need to worry, you can delete. Now our geometry is exact this way. These are the cantilever beams, we can design it manually or we can just model it. If you want, we can model it later on. So this is the modeling of your structure. So this is the modeling. Now once your modeling is done, go to general, then specification. So your material specification, first material, just assign concrete. We are giving a concrete structure, we are designing a concrete structure. Just click assign to, because all the structures, all the components are concrete. Just click on this, all the members are concrete members. So members are done, property is done. Load, we will take a different lecture. Support is done. Specification properties. So let's get into the properties. Your material, column size and beam size. So we have to define a beam size, we have to define a column size. So in our previous lecture we have discussed that we are keeping all the column sizes as 0.464 meter by 0.7 meters. Just click on define rectangular 0.4 meter, 0.4 meter by 0.7 meter. So this is your beam size, the column size. Now just for beam size 0.23 by 0.6. So this is your beam and column sizing. So now column is your vertical member, just click on column, click on select beams parallel to. So once we have selected beams parallel to Y, all the columns along your Y direction up till your foundation to your top roof level is selected. So now just click on assign to selected beam, or you can manually use cursor to assign. So just assign. So all beams are assigned, all columns are assigned. Now just go on again, go on, select option, select beams parallel to X. So just before that, just click on this, because we are assigning beam parallel to X. Now beam parallel to Z. All beams are connected. Just click on assign. So now your beams are assigned, your columns are assigned, your support has been defined. So this is the modeling part. Any extra modeling, any modification you can, if you want, you can do in your own geometry, your design. You can increase the number of stories, you can do whatever you want to do with the geometry. But there is one more shortcut. I'll just discuss it later. Just now, we can also replicate, if you can just, if the loading is throughout same, like every typical floor has the same loading, then how we have used this translation repeat, that translation repeat can also be used for the loading repeat. But we are not using it. We will just put the loading on each floor as floor wise, because we will try to segregate the loading like for different types of room. So now we are just focusing on modeling. So now modeling is done. Let's have a look how your structure will actually look. So just we will see the render view, 3D render view. This is your structure. This is your structure. So this is how your building will look. Column orientation, we will while optimizing stage, at later stage, we will be just orienting, like now it has been STAAD takes its own orientation as per its program. Like beam, you can see that beam along width, it has taken 6.6 meter, while depth 0.23. So you can just we can just do it now. Just click on this, just reverse it, 0.6 by 0.23, change, close. So we have just reversed this beam dimension. Now you can see the render view. It has just taken this, reversed. So now your depth is more and your width is less. So the orientation we can change anytime. You can do this exercise. You can keep your model ready. If you want, then you can also start doing your loading. We have already uploaded the videos on how to assign dead load, live load, the seismic load. Also seismic load I'll just discuss later on. So these loads already have assigned. You can also assign seismic loads. Just input the seismic parameters. Please refer the previous videos so that you can easily get the idea. So hope this modeling is done. I know you must be having so many doubts regarding modeling. Please come with your doubts so that I can understand at what level I need to explain the topic. I can just go. I can also go through very fast, but I just want to go in a slow and steady manner so that everything can be clear. So please come up with more doubt, so that I can explain and I can continue this series properly. If in case you come across any doubt, please don't hesitate. Even if it is a simple doubt, you can ask anytime. So please keep sharing our videos. Please subscribe to our channel and please press the bell icon so that you can get continuous notification regarding our uploads. So this was my third video on G+6 Rcc building and design. Next video will be about loading application load. Actually, I forgot to just note down a very important step, very important error which will occur when you model a structure. So we need to just take care of that error. I just forgot to uh, just make sure that we don't get any errors in. So for that you just need to click while geometry, if you'll get error in geometry, so your analysis won't be processed, your design won't be processed. So just go into the click the tools item. You have to check these things, check for multiple structures, check for duplicate nodes, members, plates. So if you have any duplicate nodes, if you have any orphan nodes, like if you have any extra nodes which has not been used, then those nodes, those members will be giving error. So just click on this. First we will just click on multiple structures. If you have any multiple structures, no, you have only one structure. So now just click on this duplicate nodes. If you have extra nodes, for zero you don't have any duplicate nodes. So now once nodes are done, click on members. Look, so many duplicate members are there. So if these members are, if you are not removing these members, then you will your analysis won't be processed, your design won't be processed. So do one thing, just click, you have to click on each and every members. So just click on merge, so that these two members will be merged as same. So duplication will be taken care. Duplication, so like just click on this member, merge. So click on this member, merge. So you can keep on doing this up till your last member is. So now look, after doing this merge beam column, your geometry won't give you any error in your design. So now we cannot analyze because we have not applied any load. So this was regarding your geometry modeling your G+6 Rcc building. So you can also increase the number of story. You can resize your beam column. You can place your beam. You can have extra cantilever beam. You can have n number of modification, however you want, as per your requirements. So hope this was clear. If you have any doubt, please come with your doubt, so that we can discuss and we can proceed further. So keep sharing our videos, keep watching our videos, and please subscribe to our channel, and please press the bell icon so that you can get continuous notifications. Thank you, take care, goodbye, and have a nice day.